the same frequency and the same severity, right?
Okay.
Okay, so you see here the frequency, okay, started going up and then going down. Yeah, so here it reaches 32% at age 18, then it goes down 22, 23, 21, 18, 17, and it goes down. Or it's still stable here, for example, okay, between 16 and 18. And how about the severity? It started low, okay, 4,000, 5,000, and increased till to 6,000, and then or still increased till 7,000, and then decreased. So you have your adjustment here. Okay, I need to group these ages based on the frequency and the severity. Okay, here you have the exposure. Also, you have to look at the exposure. This is the number of vehicles. Okay, you can't say I take 16 as one group alone. You only have 75 vehicles. Okay, in total, I have 83,000. So it's nothing. We need to make the groups by making the groups more credible. Okay, it means that it contains much exposure. So how we started here, as you see, here the frequency is very high comparing to down. Maybe I can group this one in one group because the frequency is high. Also, this is severity is high comparing to the others here. And then for this group, for example, how much you have? You have 6,000 vehicles. It's good. And then you continue. Age 24. Here's the frequency. Okay, still little high, not okay. We can stop here before it goes down. Here is still at between 22 and 23. So I can keep this, or you can keep this. Yeah. Okay, and here the severity is still high. Okay, we have some values here around 5,000, here 6,000, 7,000, here around 5,000. Okay, still high comparing to the one below. Okay, and you can see here the severity is more or less stable between 4,000, 5,000. Okay, it's more or less stable. And also the severity, the frequency is almost also stable. Or maybe you can keep this one group because, or you can take all this together. Okay, you see, it's about the judgment. It's how you see it's the best way here to choose a grouping until we have a good model.
Do we have any more technical to group the age?
Any method?
Yes. Any other method to group the age?
Yes, there is other method, but we have to read about it and to be coded. Okay, you can make research. Okay. Usually we use the k-means. The k-means, but here's the problem. What k-means work more with a categorical variables, not continuous variable. Here we have a continuous variable. Maybe if you apply the k-means, maybe it will tell you that the age 18 or let's say here the age 20 should be with age, for example, 37. It's not possible to have in one group age 17, 14, 13. Okay, and the group 2 you have 18 and 35, for example, and 22. Okay, you can't have this. You have, it's a continuous variable. You have to see from the beginning, from the minimum age till the maximum of the age. This is a grouping. Okay, for example, here, if you decide to group this in one group, for example, you call it 16, 23. It will be your new variable. Driver age, new. Okay, like this. And this one will be used in JLM model.
Okay.
Right. Okay. And you can do a research, Fyong, to see if there is a good method to cluster a continuous variable. Yeah, because also we need to cluster the vehicle age. It's the same story. Vehicle age. For the vehicle age, if you see, this is a vehicle age. Okay, as you can see, the severity is high till here. And then you go down and the frequency is high. So you can split the vehicle age here below 12 years and 13 years and above. And also you have to be careful about the number of vehicles. Okay?
Okay.
So when you do the clustering, as you said before, you will have a new variables, make nationality clustered, driver age clustered, vehicle age clustered, and then you run your JLM model, frequency and severity. Okay.
Can you show me the equation of the severity model?
Equation of the severity
The model, the example of the severity model.
The equation, how we calculate the severity?
Yeah.
Okay, the severity, it's equal claims amount divided by claims count. The severity, it means the average cost per claim. Okay, and the frequency equal claims count divided by ERP. And then the risk premium. Do you know what is the risk premium or the burning cost? Yes, Fyong?
Severity.
The risk premium.
Yes.
Yeah, the frequency multiplied by the severity, or it's the claims amount divided by what? ERP. Okay. At the end, when you say we do motor passing, we are estimating the risk premium. So first we do the model for the frequency and we get the coefficient, and then we do the model for the severity and we get the coefficient. And then we multiply the coefficients to get the coefficients of the risk premium. Okay.
Okay.
Everything clear?
Let me see. I've sent you a picture.
You sent me a picture. Yeah, okay, this one.
No, yes.
Okay, build a model for the average number of claims per contract, number of claims, export the number of contracts. This is what we said. Yeah, build a Poisson model. Yeah, it's a Poisson model. Right.
We did
This
model.
is the model. Sorry.
We will use it model or the equation that you have written.
Yeah. Here you are asking about this equation. Yeah, build a Poisson model. This one. Are you asking me about this? What is your question, Fiong?
We will, for the frequency, we will use this Poisson model or the model you have written. Or the model you have written.
Look. Okay, I got you. Wait. Okay. Okay, first, model 1 is the frequency. Okay. In JLM, what is the equation of the JLM? It's Fy equal intercept plus, or let's say without intercept, x1 plus x, wait, b1 x1 plus b2 x2. Okay, the JLM equation. Okay, this is the JLM equation. You have the x1, x2. They are the risk factors. It means the body type, driver age, vehicle age. Okay.
Okay.
And y, it's your target variable here is the number of claims, count of claims. Okay. F is your link function between your target variable, count claims, and the risk factors. Okay. Usually, F is logarithmic. If you use log of y equal, let's say, x1 plus x2. Okay. but we need y equal what? Exponential of x1 plus x2, right?
Yes.
Okay, but here y is the claims count. Okay, let's do it. Count of claims. Count of claims here. Count of claims. But Mia, what I need the frequency, right? Not count of claims only. So it's like to have the frequency. What I should do, I should divide the count of claims over ERP. Yeah.
Okay.
Okay. But ERP is not included in this equation. So what I do, I add an offset. Okay. The offset is what you showed me here. Log
Yes.
X. So here I said plus log my ERP. Okay, this one is my offset. Why I added? If you redo the equation, so the count of claims equal exponential of x1 plus x2 times exponential of log ERP, right?
Okay.
So count of claims equal exponential x1 plus x2 times what? ERP. Exponential of log equal the value, ERP. So then I will have count of claims divided by ERP equal exponential x1 plus x2. Okay?
Okay.
So here is like you have the frequency equal exponential x1 plus x2. So here's how you get your equation of GLM. Here, your predicted variable, your target variable, exponential of log ERP plus your risk factors.
Yes.
Now it's clear?
Yes, it's clear.
Ah, good. You wanted to ask me this before, yeah? You sent it to me one time, the photo.
Yeah.
Okay. So, and you can do the same for the severity. Model 2, the severity. Okay, we said, do you remember what the equation of the severity? Claims count, claims amount, sorry, divided by what?
Divided by claim count.
Claims count. Amazing, Fyong. So, also we use logarithmic. We use log of the claims amount equal x1 plus x2 plus we need to add the offset to get the severity. We add the log offset logarithmic of claims count. Okay, at the end you will have, okay, I will not write it, blah, blah, blah. You will have at the end claims count, claims amount, sorry, divided by claims count equal exponential of x1 plus x2. Okay, so the offset have an important role. This is how you how you define your GLM model. Okay.
Okay. But in severity, we use the gamma distribution, right?
What for the severity?
Yes. We will use
Yeah,
the
tell me.
gamma distribution. For
Repeat
severity,
again.
for severity, we will use gamma distribution, right?
Gamma distribution, yes. Gamma. Gamma.
What is the
For
link function? The link function of gamma distribution.
the logarithmic, it's the link function. Okay, it's a positive or negative binomial. One of these. Okay.
With the severity, we also use the link function log link, right?
Log link, yeah. For both.
Okay. And how to choose the offset?
How you choose the offset?
Yes. If the log link, if the link function is not log link, how to choose the offset?
In your coding, okay, when you add, how you code the GLM model? You write, for example, driver age plus vehicle age plus log ERP. And you find, no, I think it's an option. You